And salutations. This is Chapter 3, Part A, where we're looking at measuring in units. Now on there you do have your homework and HChem. You got your that in addition to what is listed on there. So let's get started. And you know the idea is science. Well, what is science? How do we deal with science? If you think about it, we can measure things and we can observe things. So what's measuring? Okay, observing obviously is what we see, but what is measuring? Well, if we're looking at comparing an unknown amount to a standard unit, well, something is kind of obvious. We want to measure how long somebody's foot is. That's our unknown compared to a standard unit. Think inches or centimeters. Any way we look at it, all measurements have two parts. You have a number, and then you have a measurement unit, like 4.2 grams, or 12 inches, or 5 miles. You have a number and a measurement unit. So when we look at dimensions, we can look at things like length, mass, volume, time, even electrical charge, because every dimension has some kind of a unit, with meters, seconds, etc. Now, of course, you have to have a scale, because this is the only way we're going to be able to make measurements, as opposed to observations, which is what we are seeing with our eyes, or maybe hearing, or feeling, okay, touching, tasting, smelling. Those would be observations. But when we look at measurements, we have some kind of a scale, and the scale typically is graduated. That means it's equally divided into smaller units. So on there, you notice that there's a measuring cup with milk in it. I think it's milk. Then you have a graduated cylinder. Those little markings represent the scale, the smaller units, because, you know, if you had a beaker that says 50 milliliters on it, and you have a graduated cylinder that has 50 milliliters on that, guess what? The 50 milliliter beaker doesn't have the markings that the cylinder has. Moving on, metric system. Real fast. It originated in France after the French Revolution. It's based on the decimal scale of 10. It's otherwise known as the Système International, or the SI. So SI and metric are the same. The 10 units is because that's what people could count on their fingers. Now, they try to do a 10-day week. Guess what? Disaster. God ordained the 7-day week, like in Genesis 1. Now, in the metric system, you've got 7 basic units that we work with. In chem, we're not going to work with all of them, like the length, the mass, time, temperature, number of particles. All those we're going to be working with. The length's the meter, mass is the kilogram, time is the second. The temperature, the absolute temperature, is the Kelvin. There's no such thing as negative Kelvin. Don't worry, we'll get there. Number of particles, the mole, we're going to get later on in that. Electrical current is the ampere, and then the light intensity is the candela. So, prefixes. The cool thing about the metric system is it doesn't matter if it's volume or length or mass. The prefixes are the same. So you see quite the selection here, where you got mega. Well, most people are familiar with kilo. 1,000 of anything. Deci, 1/10. Centi is 1/100th. Then we deal with milli and micro and nano. So this is just giving you an idea of all the prefixes that are there. Okay, zeta, yada, zepto, yocto, atto, femto. I like those. That's fun. Pico. Yeah, real tiny, tiny, tiny. So, great. But what happens if you are working with one system of measurement, but you need to change it to something else? That's where we have conversion. And the conversion factor is the number you use to change from one unit to another. So a conversion factor is kind of like a currency exchange, like $1 is equal to 2 euro. That's a conversion factor in money, in the real world. But for us, 60 seconds is 1 minute, 24 hours is 1 day, 12 inches is 1 foot. Okay? So we have that. Then we have something called the bridge notation. And this is one way to multiply and divide several measurements together at the same time. And it does make it a little bit easier. So for example, if you wanted to know how many seconds there are in a day, okay, what we know is 60 seconds in a minute, right? We know that there's 60 minutes in an hour, and we know that there's 24 hours in a day. All those are examples of conversion factors. So we can take those and put them down here, where you can see it looks like a little bridge there, and we can solve the problem, multiplying it across. We're going to work on that a little bit more in class. So if you don't totally get it right now, and it's not the night before the test, that's okay. There are ways to do this. And with that, ladies and gentlemen, we are completely done here for Chapter 3A.